Well, hello everybody. Well, here's what I need to cover with you today. If you missed class or I was gone, whichever occurred, in this case you must have missed class, what I need to do with you today is cover our Day 10 class example sheet, which is called Radicals. So in the upper right-hand corner it should say Day 10 class Radicals. What we do today is we reduce square roots. What we're building to is how to work with what's called the quadratic formula. The quadratic formula you've probably seen before. It looks like this. The opposite of b plus or minus b squared minus 4ac all over 2 times a. We're building to work with that. What I'm going to do today, though, is I'm going to focus on how to handle the radical parts of it. So if you would, look at your class examples there. Notice that I've given you a worksheet or a chart up in the top. We're going to fill that chart out. And what I mean by fill that chart out, the bottom row we're going to generate numbers that you should know the square roots of. Those are numbers that we enjoy seeing because they have a square root. So we're going to quickly fill out this bottom. So I'm going to take the number in the top, in this case 2, I'm going to square it and get 4. What does that mean? It means the square root of 4 is 2. The next number, 3 squared, is 9. Once again, it means the square root of 9 is 3. So the numbers in the bottom row will reduce nicely for us. Let's go ahead and just fill out the rest of that. We should see a 16, a 25, a 36, a 49, a 64, 81, a 100, and a 121, a 144, a 169, a 196, and if you got room to go one more row, put a 15 there and a 225. Now, the bottom row is really going to be key for us. Those are numbers that we know the square root of. So my numbers 1, 2, 3, and 4, those are easy because those are already perfect squares. The square root of 169, it is 13. What does that mean? It means 13 times 13 is 169. So that's what it means. Now my number 2, it says the opposite of the square root of 81. Well, let's take care of the opposite of. I know my answer is going to be negative because that's what's out front. The square root of 81 is 9. Here goes my number 3. We haven't dealt with that plus minus out front. That just means there's 2 answers here. There's a positive version and a negative version. Well, the square root of 400 in this case is 20. We could have typed that in your calculator if you need. And then number 4, don't be scared of fractions. I got positive or negative. I'm going to think of this as the square root of 16, which is 4, over the square root of 25, which is 5. So there we go so far. Now, I'm going to slow down a little bit on my next little group. On 5 through 20, or 5 through the rest of them, I want to break down the radical. Notice that we do not know the square root of 20. 20 does not show up in our bottom row, so it's not a perfect square. But now here's how we're going to handle this, and here's the work you got to show me. We're going to write this as something that we know the square root of and something we don't know the square root of. So we need to find one of these bottom numbers that goes into 20 nicely. This one's kind of easy. 4 we know the square root of, which leaves me a 5. Now when I reduce this, the square root of 4 is 2. The square root of 5 is the square root of 5. We're all done. So the key is, write it as something that you know the square root of times something that you don't. Now, number 6 is a bigger number. I know my answer is going to be negative because there's a negative out front. Now here's how I break down the radicals. I need something I know the square root of times something I don't. I take half of this number. Half of 72 is 36. So I'm going to start looking right here. I'm going to look at these numbers and see if any of them goes into 72 nicely. And I'm going to start from the biggest I can. I could start here at 49. If I go 72 divided by 49, I get a decimal. I don't want a decimal. If I go 72 divided by 36, though, that's a good thing. That tells me that 36 times 2 is 72. Now when I reduce this, the square root of 36 is 6. The square root of 2 is square root of 2. And then we have it. Here goes my number 7. I know my answer is going to be negative. I'm going to write it as something I know the square root of times something I don't. So once again, here's how I attack it. Take around half of the number, just so we have a place to start. Half of 125 is around 60. So I'm going to start looking at numbers right here. I'm going to look at the 64, the 49, the 36, the 25. I'm going to stop at the first one that divides into 125 nicely. So when I go 125 divided by 64, I get a decimal. 125 divided by 49, I get a decimal. Divided by 36, another decimal. Divided by 25, now I got something. 25 goes into 125 5 times. So guys, you want a number that you know the square root of here. That way when I reduce this, the square root of 25 is 5. The square root of 5 is 5. So my answer, negative 5 radical 5. Looking at the opposite of the square root of 48, there's a negative. So once again, I need to find a number that goes into 48 that we know the square root of. So once again, I'm going to take around half of it. Now when I say around half of it, that's just so I know where to start. That way I don't start and waste my time. Half of 48 is 24, so I'm going to start looking right here. I'm going to ask myself, 48 divided by 25. If I type that in my calculator, decimal. 48 divided by 16. That works nice. So I'm going to think of this as 16 times 3. So I've got the square root of 16 times the square root of 3. The square root of 16 is 4. The square root of 3 is the square root of 3. So there it is, reduced. Square root of 108, something I know the square root of, times something I don't. Just to start, I'm going to take around half of 108. So I know that's around 50. I'm going to start somewhere around here. I'm going to go 108 divided by 49. Not pretty. 108 divided by 36. That's pretty. So I'm going to write this as 36 times 3. The square root of 36 is 6. The square root of 3 is 3. So there's my answer. It's called reducing radicals. Number 10, we're working with the number 80. So come up here. Let's try 80 divided by 49. Nope. 80 divided by 36. Nope. 80 divided by 25. Nope. 80 divided by 16, though, that works. Tells me that 16 times 5 is 80. The square root of 16 is 4 times the square root of 5. Now what I did in class, guys, is I had your classmates do 11, 12, 13, and 14. We'll just click right through them. You can pause the video right now and try them before I fly through the answers. But 18, I'm going to think of as the square root of 9 times the square root of 2, which is going to leave me 3 radical 2. 60, I'm going to think of as the square root of 4 times the square root of 15. The square root of 4 is 2. The square root of 15 is just the square root of 15. Number 13, 50, 75, 100, 125. Those are nice numbers to work with because 25 goes into all of them. Think about if you had 2 quarters in your pocket. You would have 50 cents. Well, the square root of 25 is 5. The square root of 2 is square root of 2. And then my number 14, square root of 600. Anytime something ends in a double zero, 100 is an automatic square root. Then the square root of 100 is 10 times the square root of 6. Now, I'm not going to add a lot to it. I'm going to show you how to handle it when the numbers get a little bit bigger. The steps are the same, but a couple more things just show up. So here goes your number 15. Notice that number 15 is just like your number 5, except for number 15's got a 3 in front of it. Well, the way we're going to handle this, we're going to write down that 3. Now we're going to pick on the square root of 20. I need a number that goes into 20 that we know the square root of, which could be 4. Leaves me a 5. Now, there's just an extra step now. The square root of 4 happens to be 2. So now I've got 3 times 2 times the square root of 5. Well, 3 times 2 is 6, square root of 5. So moral of that story, you still got to reduce the radicals. Just use the number there at the end and multiply it by your whole part. Number 16, I'm going to write down the 5. We need to go find a number that goes into 24 that you know the square root of. So once again, how I do it is I take half of 24, that's about 12. So I'm going to maybe start with 16. In my calculator, I'm going to go 24 divided by 16, ugly decimal. 24 divided by 9, decimal. 24 divided by 4, there we go. So this is the square root of 4 times the square root of 6. Well, this now becomes 5 times the square root of 4 is 2, times the square root of 6. 5 times 2 is 10, square root of 6. So that's all we got going, guys. Come to your next little part, if you would. Let me show you how to combine radicals before we break them down. What I'm going to do on number 17 is I'm going to combine these radicals first. I'm going to think of this as the square root of 6 times 24. In my calculator, I'm going to go 6 times 24, and I'm going to get the square root of 144. This is what I'm going to try to reduce. And in this case, that's sweet because the square root of 144 we know is 12. So that answer is just 12. 18 is another nice one. I'm going to go 3 times the square root of 8 times 18, which is really 3 times the square root of 144. This now becomes 3 times the square root of 144, which is 12. My answer is going to be 36. Now, number 19 is not as easy. Not as easy. I'm going to go 2 times 5, the 2 whole parts. 2 times 5 is 10. And I'm going to go the square root of 40 times 20 is 800. Now, I'm going to solve this the way your classmates did. Your classmates did not see the best number to use. They saw a very good number to use, but not the best. So I'm going to do what they did. Here's what they saw. They said 10, and then they said, let's do number 19 like we did number 14. It ends in 2 zeros, so let's go 100 times the square root of 8. Now, when I simplify this, I get 10 times 10 times the square root of 8. But the square root of 8 reduces some more. So now I'm going to start another line. So I've got 10 times 10 times, I'm going to think of 8 as square root of 4 times the square root of 2. I now have 10 times 10 times 2 times the square root of 2. Now we can finally go get our answer. 10 times 10 is 100, times 2 is 200, times the square root of 2. Now, if you would have saw it, when we had 10 times the square root of 800, if you would have saw the best number, it would have been a 400 and a 2. Now the square root of 400 is 20, so I got 10 times 20 times the square root of 2. 10 times 20 is 200, radical 2. So guys, there's multiple ways to get the answer, but if you do it correctly, our ending answers will be the same. Our ending answers will be the same. Now, some good news at this point, we're not going to talk about number 25, 26, 27, 28, 29, and 30. So you can scratch those out. I am going to show you number 20, 21, and 22 real fast. Like I said, what I'm getting to is breaking down, knowing how to use the quadratic formula. So here's what I'm going to ask you to do. The square root of b squared minus 4ac plays a very important role in the quadratic formula. The b squared minus the 4ac is called the discriminant. So I'm going to get you some work with the discriminant today. So what I'm going to ask you to do is I'm going to ask you to evaluate b squared minus 4ac. So in place of b, I'm going to put a 5. Get in the habit of putting that b value in parentheses, whether it's positive or negative. If it's negative, you've got to use parentheses. If it's positive, it doesn't matter. But I've got 5 squared minus 4 times 1 times negative 6. Now I'm going to ask you to grab your calculator and go 5 squared minus 4 times 1 times negative 6 equal, and you're going to get 49. My second step then, I'm going to think of this as the square root of 49. And the square root of 49 happens to be 7. So I'm going to do number 21 and 22 with you, and then I'm going to shut it down. That'll be all I'm going to do on the video. Should make the video a little less than 20 minutes, so that's not a bad video. Here's my number 21. Once again, we're going to take b squared minus 4ac. My b value is negative 21. So put that in parentheses and square it. Minus 4 times 10 times 9. If you don't put that negative 21 in parentheses, you get something like negative 801, something way wrong. If you put that 21 in parentheses, you're going to get 81. And it's going to become the square root of 81. The square root of 81 is 9. So these two reduce nicely. My next one won't, and I'll show you how we'll handle that. So my last one, I'm going to go b squared minus 4ac again. My b value is negative 9, so I've got negative 9 squared minus 4 times a times c. If you run that part through your calculator, you're going to get the square root of 41. The square root of 41 does not reduce because it's a prime number. So here the answer is exactly, if you run it through your calculator, if you hit your square root button and 41, you're going to get about 6.4. Okay. So guys, assignment-wise, you should have what's called Day 10 assignment. What you will do on that assignment is you will go 1 through 30. You'll do 1 through 30. You won't have to worry about 31 through 36. Okay? Good luck. If you have any questions, get in before school, after school, during seminar, and I'll get you straightened out. Good luck.